In this lesson, we're going to talk about systems of linear equations. A system of equations consists of two or more related equations. There are some situations that require more than one equation to describe them. In those types of situations, we need a system of equations. The solution to a system of equations is an ordered pair. It's a point, and that point satisfies every equation in the system. In other words, if you plug that point into each equation in the system, it works. It makes each equation true. There are three possible outcomes when you're trying to solve a system of equations. You may have just one solution to the system. You may have no solution to the system at all, or there may be infinitely many solutions for that system. These three graphs illustrate the three possible outcomes. In this graph, we see two separate lines that cross in a single point. This point is on both lines, which means it works in each equation. This is a system that has just one solution. In this graph, we also see two separate lines, but they don't cross at all. These two lines are parallel. That means they have no points in common. So there is no solution to this system. There is no point on this line that also works when we plug it into the equation of this line. Lastly, we could have two lines that actually share all of their points. In other words, they're really the same line. In situations like this, you have an infinite number of solutions for the system. Any point on the line will work in both equations. When a system has at least one solution, we say that that system is consistent. And when the equations in a system graph into two separate lines, we say that those two equations are independent. So in this first graph, we would say that this system is consistent and that its equations are independent. For the system in this second graph, we would say that this is an inconsistent system since there's no solution, but the equations are still independent since they form two separate lines. For this last graph, this is a consistent system, but the equations are dependent. In this video, we're going to look at three methods that we can use to find the solution to a system of equations. First, we can graph the system. Secondly, we can use a method called substitution. And lastly, we can use what's called elimination. Substitution and elimination are the two algebraic methods of solving a system. In this video, we'll focus on using the methods to solve systems that are consistent and independent. The other two kinds of systems are special cases, and we'll work with those in a separate lesson. To solve a system by graphing, first graph each linear equation. Then look for the point that lies on both lines. That'll be the point where the lines cross. Here are our two equations for this system, x plus y equals 5 and 4x minus y equals 5. In order to graph these equations, we'll first rewrite them in the slope-intercept form. For the first equation, we'll subtract x from both sides to get y by itself. Now we have y equals negative x plus 5. Our y-intercept is 5, and the slope of the line is negative 1. So we'll start by graphing our y-intercept, and then using the slope to find more points. A slope of negative 1 means we go down 1 and to the right 1. And here's our first line. To get the second line in slope-intercept form, we'll first subtract 4x from both sides. Now we divide both sides by -1 to get y all by itself. So we have y is equal to 4x minus 5. Don't forget to change all those signs. To graph this line, we'll first graph the y-intercept at -5. And a slope of positive 4 means we go up 4 and to the right 1. I'll try to draw a straight line. And there we have it. Our intersection point is right here. That's the solution to the system. The coordinates of that point are 2, 3. And this means if we were to plug x equal to 2 and y equal to 3 into both of these equations, it should work. It should make each equation true. That's a way that you can check to make sure that you have the right solution. Solving a system of equations using graphing works well if the coordinates of your points are integers, positive or negative whole numbers. But if your coordinates turn out to be fractions, it can be hard to read those coordinates from a graph. So we also like to use the algebraic methods, either substitution or elimination. In using our two algebraic methods, our goal is to work with the two equations so that we end up with an equation that only has one variable. When we get that kind of equation, we can solve for that one variable. After we know the value of one of the variables, we can plug that in to find the value of the other variable. Both substitution and elimination achieve that goal. They just do it in different ways. To solve a system of equations using substitution, first, you're going to take one of the equations and solve for one of the variables. Usually, you pick the one that's easy to get by itself. Once you have that variable by itself, you're going to take that expression and substitute it into the other equation in place of that variable. That's the magic that gives you a one variable equation. Any equation with just one variable, we can solve. Once you know the value of one of the variables, you can substitute it back in to find the value of the other variable. Solve, then substitute, solve, then substitute. Here we go. 6x plus 2y equals 5, and 2x plus y equals 1. In this system, the variable y in the second equation has a coefficient of 1. So it looks like it would be easy to get this y by itself. Let's subtract the 2x from both sides and do that. Now this equation is y is equal to negative 2x plus 1. We've solved for y. Now we'll take this expression for y, since this is what y is equal to, and we'll substitute it in for y in the other equation. Solve, substitute. Let's write our new equation down here. 6x plus 2 times, now instead of y, we'll write the expression that y is equal to, negative 2x plus 1. And that is all equal to 5. Here's the equation that we can now solve for x. First, distribute the 2. 2 times negative 2x is negative 4x. And 2 times 1 is 2. Combining like terms gives us 2x plus 2 is equal to 5. Subtracting the 2 from both sides gives us 2x is equal to 3. And dividing both sides by 2 gives us x is equal to 3 over 2. We found x. Now, let's take the value that we just found for x and substitute it back in to one of our original equations. That will allow us to find y. You always want to plug your value back into one of your original equations. So I'll pick this one. 2 times x, which is 3 over 2, plus y is equal to 1. Let's work this out to get y. 2 times 3 halves, 2 is the same as 2 over 1, and my 2's cancel here. So I'm left with 3 plus y is equal to 1. Subtracting the 3 from both sides gives me y is equal to negative 2. We found y. So the solution to our system is the ordered pair 3 over 2, comma, negative 2. And it's always a good idea to plug your answer back into both equations just to make sure that it really works. Let's do an example of substitution now that's a little more difficult. 4x plus 3y equals negative 7, and 5x is equal to 2y minus 3. Remember, solve, substitute, solve, substitute. It looks like it'll be easy to get x by itself this time. All we have to do is divide both sides of this equation by 5. That gives us x is equal to 2/5 times y minus 3/5. We've solved for x. Now let's take this expression and substitute it in place of x in the other equation. That's the magic that lets us write an equation that only has one variable. Be careful to copy each part of the equation correctly. So here's our equation, and we need to now solve it for y. So let's start by distributing the 4. We have fractions here, so let's go ahead and write 4 as 4 over 1 and do the multiplication. 4 times 2/5 is 8 over 5. 4 times negative 3/5 is negative 12 over 5, plus 3y equals negative 7. Now we combine our like terms. 8/5 y plus 3y. 8/5 plus 3 you can do on scratch paper or in your calculator. You'll get 23 over 5y minus 12/5 equals negative 7. Now we need to add the 12/5 to both sides. So we have 23 over 5 times y is equal to, and negative 7 plus 12/5 is negative 23/5. And lastly, to get y by itself, we need to divide both sides by this fraction, 23 over 5. On the left-hand side, the two fractions cancel. Anything over itself is 1. So we're left with just y. On the right-hand side, you can do this in your calculator, or you can notice that 23 over 5 is the same. So negative 23 over 5 divided by positive 23 over 5 will give you a negative 1. And there's our value for y. Now that we have y, we can take that number and substitute it back into one of our original equations. Doesn't matter which one. We plug it back in so that we can then find x. So we write negative 1 in place of the y. Now let's work to solve this for x. 3 times negative 1 is negative 3. Adding 3 to both sides leaves 4x on the left-hand side and negative 4 on the right-hand side. And then dividing both sides by positive 4 leaves x on the left-hand side and negative 1 on the right-hand side. So we have that x is equal to negative 1 as well. So the system is consistent and it has one solution.